Hello, welcome back to ABI-DOS. Still can't pronounce his name. That's alright. This time we're going to be continuing after the 9 segments done before and after a pretty interesting level here. And then moving on to data size calculator and call corrector, whatever those mean. So it is, I assume, calculates the number of items in a given set of data. That's what I would assume. Alright, let's check it out. Oh my goodness, what are these symbols? Alright, so okay, I see what they want me to do here. It's basically calculating how many like OK symbols there are between each set of red hashes. So that is a data size calculator. Supplies a sequence of data packages sending with a hash symbol. Yep, okay. So each data package contains these like battery bars. That's what it looks like to me. And then they are separated by hash symbols. For each package, tally the number of items excluding. Sorry, I don't know why I read that wrong. Excluding hash symbol and transmit that count to S5. Obstructor is available. This is an obstructor. That looks like it. Stops the U-bit for X cycles. It releases the U-bit. So after that. If X equals -1, stops the U-bit indefinitely. Okay. When any sensor triggers a transition state to B, it becomes inactive for 1 second and releases. Oh, this is triggerable, I see. The state A cannot be modified by the user. Oh, so it's triggerable locked, that's why. Okay. Yeah, okay, so it holds on to a bit for a certain amount of time. I guess a hash, probably. We want it to hold a hash. Not sure. If a U-bit collides with another U-bit held by an obstructor, the countdown will be transferred to the resulting U-bit while the values are added as usual. So if something hits something on an obstructor, the countdown continues, right? Yeah, the countdown continues. Transferred to the resulting U-bit that shows up, and the sums are that they sum together. Whoa, cyan bar. A U-bit approaches an obstructor, it's stopped indefinitely. And a U-bit triggers a true condition, it will then release it. If held indefinitely. Okay. Or if held at all, I think. So it either releases after a period of time, or it releases... Okay. And B and A... set a trigger by icon to state B or state A. I can set a state B to connect to this if I want to. What's B? Breakpoint. Press the simulation right before the start of the next cycle. Reduces the countdown of nullified events by 1. I'm confused because I don't think this like does anything special for me. I think it just does. So we need a counter. We didn't make a counter. Okay. How to make a counter. Colorizer. I know how I can use the obstructor to basically make a start-stop operation here. But I guess I could how to set the number is what I'm thinking. Like, how does a counter even work here? How do I have a counter work? Adds 1, maybe? Subtract or what? Oh, that's a fair. Okay, yeah. The adds 1 thing, possibly. That's held onto the obstructor. No, wait, but... Oh, you know what? No. I can make it so that each of these convert to the value 1. And then they add together. That's why the text allows me to... the text tells me about what happens if collision on an obstructor works. Yeah, okay, I see what they want me to do. They want me to basically obstruct a battery bar and then continuously obstruct the battery bar as more battery bars are added onto it. Okay. Alright, I see what they want me to do here. So they want me to first sense for the value of hash or not hash, which I can do with an ET sensor. If so, then a conveyor works like this. I guess I could use a single turn conveyor. Doesn't really matter to me, because it's only one stream coming out. Doesn't really matter in this case. So let's set to hash. Let's have something run through and then a red wire that connects these two. If this is a red hash, I would like it to activate and go upwards. Otherwise move forward. Okay. I'm just gonna have this first just to check. Make sure it's working. So if it's correct, it goes forward. If correct, goes forward. If correct, goes forward. If wrong, it goes up. Okay. And this hash basically is the thing that triggers the obstructor, because the hash will signal the end of a data package. So what the end will do is the end will immediately go to trigger the state B, because yeah, state B is when the inactiveness of the obstructor occurs. So I can set another thing here. Okay. Oh, this is helpful. Okay. We don't want it to be held for one turn, we want to help it for an infinite amount of turns, so that no matter how many U-bits are in the package length, or in the package, how many U-bits are in the package, it doesn't matter how many, it will just stay. So we'll just try this first. It gets held. Oh, but it never actually triggers the next one, so it has to flip like this, I think. Like this. Triggers next one, and they sum, and they sum, and they sum until that happens and it goes away. But of course I don't want to sum the value itself, I want to sum the count. So I want to set everything to 1 first. Except the hash, I don't want to sum the hash to 1. Okay. So I will... The trigger should come out soon. And in fact the trigger should probably come out like at the very beginning. Yes, no? If the trigger were to come out first, wouldn't that break some things? Set the equalizer to... Oh, also, this should be white. Set the equalizer to 1. This counts 1. It doesn't count the right thing. Yeah, there's too little time between these, so there should be a bit more time. We don't want it to be too much time, so I don't want it to be pushed all the way down here. So it should be like, you know, at least 1 period of time, so that, yeah. The only issue is that when this comes out, will this have been far enough added to it? Yes. Wow, okay. And that seems to work for this section. That's a pretty long signal. Was it 6? What did it add? Oh yeah, no, it is 6. Yeah, I don't want to count it 5 battery bars here. But this is correct. This means that this is probably the right setup. There you go. It's not very centered, but who really cares, right? There you go. So yeah, overall what happens here is it sends everything in and counts it by setting this value equal to 1. I don't need to know the actual value of the object, I just need to know how many objects there are. So setting it to 1 is fine. If I wanted to know how many objects there are, a duplicator to save the data would be helpful, but in this case you don't need to. However, if it detects a red hash, it will immediately stop the count by letting go of the count and sending it to the exit. So yeah, if it detects a red hash, it sends it to the exit. And there is fortunately enough time for the count to be added such that the hash still allows the last bit of data to be added before it activates it. So that works out for us. And now I can set it to infinite speed, essentially. Solve it. Very nice. Yeah, that is a pretty simple exercise, I'd say. Cool. Okay. Time to exit. I wonder what the color test 3. Uh-oh. I want to see overall what my percentile is. Looks like my space percentile is pretty low. People have used less space on this. I wonder how. But my icon percentile is still higher than usual though. So I've used less icons than required, but somehow more space than average. That's a bit weird, but I guess, yeah. Because I think that space and icons would kind of go hand in hand, right? The more icons you use, the more space I have to use. Unless icons means not... Yeah, unless the icons just means... I don't know. 1, 2, 3, 4, 5, 6, 7. No, every one of these are icons. Okay. This might have been like... This is not the minimum, as it turns out. I'm pretty sure this is the minimum though, is it not? Don't you need every single one of these? How do you have less icons? How did anyone get 6 icons to do its work? What? I mean, okay. Sure. Anyway, we now got 2 more to work with, but I think we'll be going to call Corrector first. Yeah, call Corrector. What does this mean? Oh, so what's it, this boldness challenge thing? What does that do? It's still locked. Icons when drawing. Yeah, okay. What the heck is going on here? Okay, it sorts, I think. It just sorts so that the data comes out with the hash at the back. It's 192 then hash at the back, 3237 then hash at the back, 722 hash, 87 hash, 3124 hash, 758 hash. Alright, and then all these blue ellipses don't do anything. They just throw them away. Okay. The program reformats incorrectly dialed phone numbers. Oh. Is that what this is? These phone numbers are so weird. But alright. So it's called call corrector. I was like, is this like a coding term that I'm not familiar with? It's not. Okay. S0 generates sequences of numbers that include a single hash symbol inserted at any position, followed by 1 or more ellipses, such that each length of data is the exact same. Retrieve, adjust them so that the hash symbol is always at the end, and then transmit to S5. We have no new... Okay, we have no new symbols here, but I think I might know what they want me to do, yes? Okay, then they teach me what a blue wire does. Okay, which it's basically the same as a red wire that allows signals to cross each other without connecting to each other, basically. Okay. But I guess I know what they want me to do. They want me to collect the hash, then obstruct it using an obstructor until everything else is passed through and then send the hash in. So perhaps what I want to do is also have a sensor for ellipses, because the ellipses will mark the end of the sequence in each package, yes? Yes, so... Okay. We will have the... Is this the... No, we will have the equal sensor. Alright, they give me more space here, which I would assume I would need. What I want to do is first... I need to sense a couple of things first. So let's start from the very beginning. Let's start from the corner, because I still want the input to be exactly 2 away, like how we drew it up in like every other sensing thing. Okay, so I want a sensor to sense for hash first, which is 151, that's red. We don't actually need to know its color because there is no hash of any other color. So we don't have to specify that. We just need to specify it as a hash. And then we need to hold it up, so not duplicate the conveyor. That will pull it up if active. Okay. So red. And then I gotta test things out, obviously, so let's see. Oh, hold on. There should also be one here. So if red goes up, if not red goes forward. Okay. Cool. Then the obstructor has to hold on to it. And obviously I want to hold it on to it like at the latest possible position when I go back in so that it goes in as fast as possible after the blue ellipses is detected. And this is the one that will detect the blue ellipses, which I believe the code is 181. Yeah, 181 is the code. I remember that. Yeah. So we'll hold on to this indefinitely. So that's why I put a -1 there. And then when detecting an ellipses, which marks the end of the sequence in its data packet, we'll move forward. And I think we'll move down, right? Because down is the direction that everything will go in. If it goes this way, it will turn right to move down. If it comes from here, we'll just go straight. And that will activate this. Issue is though, I don't know if this actually works out. Because like all the ellipses start coming out. So ellipses, checks for ellipses, if so, comes out. Of course, if it checks for ellipses, it should also push out the ellipses. We don't want to send out the ellipses, yes? Yeah. Okay. So we need something else here. Oh, also need a red wire to connect it to. That's why nothing happened when the ellipses passed through. Of course, I will need the ellipses. Wait a minute. Is this why the blue wire comes in? Then you connect it to different systems. I don't know. But we know the ellipses will get destroyed. So let's just check this out first. So if red held, push, push, push. If blue comes through, gets destroyed, all the blues get destroyed. And it looks fine to me. 3 held, push, push, push. Blue ellipses marks the end. It will go out. Yeah, no, this seems to work. Ellipses keeps going out. And of course, because there's a set distance between this and this, it's gonna be a lot slower. Now I can make it faster by duplicating so that the sensor and the conveyor happen at the same time, which will definitely speed things up. But it requires a lot more icons, and I can see how it's done. I'm not sure if I want to optimize it to do that though. But I'm pretty happy enough with this thing already. Is there anything I can do to... I can make U-bits transparent by holding Q. Oh, that's nice. What else can I do? Can I hide the icons themselves? If I can, I don't see it. Nope. Oh, I can still make the things transparent though. But hey, alright. This was also a pretty decent exercise in understanding what I had to do with sensors. And there you go. That seems to work so far. And over long tests. Wow, there's some like completely empty ones in here. Yeah. Cool. Oh. You can see the occasional red thing coming out here. That marks a hash. Yeah, so you're completely empty. Why would that be? Is it just each signal packet at the very end just doesn't have any numbers in it? That's possible. Oh, yeah, it just... Oh, wait, well, it just skips all of the ellipses. Why? Why would it do that? I don't know. Okay. Cool. Time to go. That was kind of nice. Let's see how... This, oh my gosh. Okay, there's a huge jump at this area, so it could be done way, way faster. And I'm thinking I might know how it's done. Oh my god, percent on 98 icons. I think this might be the best it gets. I know some people mentioned doing like 6, but yeah, no, 9 seems to make a lot of sense as well. Alright, 74% in cycles is also pretty good. I don't know who did it in like 17,000, but there was one that was way, way longer, I think. It's really hard to tell here though. Oh, people did the color test in 197 cycles. Alright, hold on. Let's see if I can copy to save slot 1 and enter. Let's see what we can do better here. I was thinking to make this faster, the duplicator can the signal caller, or this thing, whatever it's called, this guy, input. The input signal can in fact be directly after this under certain conditions, if it duplicates and allows these to occur at the same time. I don't feel like doing it though, because I have to do the exact same thing with this. How about I give up and say no? Let's erase the slot. Yeah, we'll just keep save slot 0 and be happy enough with the solution. Sure. Next up, it's a pair. We haven't seen this one at the start of the episode, but it showed up. And this would be the 12th segment. I think we'll get another achievement after this. Cool. Alright, what does a pair want me to do? Whoa, okay. It's a very thin list of inputs. Code, letters equals value greater than 99. Read S0 and S1 as pairs, so read 22 and 2 here. If either of the values contains a letter, send both to S5 in that order. Otherwise, disregard. Okay, so disregard the 2 and 22 because those do not contain letters. 50 and F do contain letters, and then send both to S5 in that order. So you'll send 50 then F. C and 8 contains a letter, so then send C and 8. C and C contains a letter at the very least, so send both C and C. D and 1 does, 85 and E does, and so on and so forth. The next one that doesn't is 25 and 7. You can see after C and C, you just skip that and move on to G and 5. Okay. We have 2 more, greater than or less than. Alright, and I see now we can use greater than or less than to sense for letters and non-letters using 99. Okay. In every simulation, the sequence of interactions is always such. Qubits collide. Interacting with icons comes after collision. And then output ports. Okay. I wonder why that's useful. Oh, that's why. So this time they're teaching us about OE, order of execution. In Baba's view, it's called OOO, which is order of operations. So yeah, icons trigger in a certain order. So some of them, sometimes, it works the way you want it to, sometimes it won't. If 2 icons with different order of execution are triggered at the same time, only the icon with the highest. What? Oh. So if it senses an equal to and not equal to at the same time, the one with the highest order. This one's an order of execution, not order of operation. Okay. If they're the same, then the one in the lowest row and the rightmost column. So the OE is then regarded as such, where the higher the number, the more it takes priority, basically. I wonder how that's going to become useful eventually. I don't know. Anyway, we do need some detectors. Okay. Let's see, we probably want to use the greater than to detect for letters. We know letters have a value greater than 99 as stated here. Okay. Test for greater than 99. If so, trigger state B. If not, revert to state A. Cool. So we'll have state A for the numbers. Okay. How do I set it to... I can set it to binary. I can set it such that all numbers are then converted to 0. I can set it such that all... But I don't want that because some numbers are actually useful when paired with letters, right? I will have to... I can't sum them both because then the numbers will just vary wildly. Like yeah, there's a 94 and 6 here, which when added and sent through here will actually trigger it, which would make the program think. And there's a letter in it. I don't want that. So how to make it so that... I'm making an OR gate, am I not? Yeah, I'm making an OR gate. So if at least one of the things fulfills the conditions, it lets them both through. How to make an OR gate though? I'm still trying to figure this out in my head. How to make an OR gate. Because I can't just send one out if it fails, right? Because the other one might pass and then the entire system would have to let it through. And of course I need to keep the value of the data. I can't just set it all to 0 if it's a number and then add it up together. So maybe a duplicator becomes useful here. Yeah, I think a duplicator might become useful here. So the OR gate can be in the center, we'll have the thing come out the side. We start off with the duplicator that separates, that gives you 2 streams. Each stream checks for positivity in terms of that. And of course, for all sensors, the let's have the... We only need one. We only need one to have an output. I said while the outputs pull everything again. Okay. So that's a sensor which then senses, and then we need a conveyor that changes direction here. So... Okay, connect. Same thing here. If greater than 99 is a letter which then... A letter should not pass. No, actually it doesn't really matter. That doesn't really matter. Alright, let's just have exit to see what this does. Oh. Yeah, same here. I want more destructors here to prevent any contamination of the data. Okay. This is slow. But we can test one by one. If number forward, if letter down, if number forward, if letter down, and so on and so forth. Alright, we have made a sorter. Very nice. Or 2 sorters side by side. Maybe I do in fact want the outputs to be the same so that they can work at the same time. And of course, I still need to set if letter, which we know moves up, yes? Yeah, letter moves to the sides, numbers move forward. If number set to 0, if letter set to... Well, I guess you can just take the letter's value. And then we sum them. And if that sum is 0, then we can trigger the thing to release the values? Yeah, okay. Can I rotate? I can. Oh. Out of bounds. How do I rotate? Can I not rotate? It looks like I can't rotate a thing. Alright, well I was... Wait, no, this is this is a square. What's the point of rotating? There's no point of rotating in a square space. Why would I do that? I do need a lot more space though, which might become a problem. Because I have used so much space here. Okay, so anyway. What I wanted to do is I wanted to merge and check for... I wanted to merge and check for zeros. But obviously... something very off is going to happen here. Like, there's so many things to work with. What if I had this be on, like, further up instead, and then this be going downwards, and this be going upwards, so that they merge more cleanly. These can still merge, right? So they can all just merge together, because you only work with 2 streams of data at once. Just have them all merge. Although I do need them to merge at the same time. So I think this have to be down by 1. And then we just have conveyors that push everything forward. This doesn't have to push forward. This has to push forward, yeah. And then we need a sensor that senses for the value of 0. This is a lot to work with. And then delete that sum because we don't need that value anymore. Whoa. Right. Okay, and of course you need them to be the same distance apart because everything is timed to the same. So if same merges, if 0 triggers, if not, does not trigger. Yes, okay, this seems to work for the triggers and 0 and does not trigger on 0. That's what that we want at 0 that comes through. Okay. Okay. Now I can pack this to a much more compact space, so just to make things a bit easier for myself. This is a much more compact space. We just backward routing. Whoa, but the timing is off now? What? Oh, yeah, it is. Okay, this has to go up by 1 then. Whoa, what the heck is going on here? Okay, yeah, no, this is right though, yes? Yes, this is right. Okay. Then, we need a conveyor if... Not conveyor, if yeah. That the 0 will trigger 2, so... we don't need blue, let's just continue using red. We do have space here. So this will trigger this and this. If correct, the... Oh wait, no, this is a holder. This is the hold. Otherwise it will just bounce back. There's an obstructor. Wait. But then... Oh, then it needs to continue triggering the next one, which is a conveyor, which will... Yeah, okay. So besides the obstructor, which will hold it until its value has been tested, it also needs a conveyor that will send them out. I guess straight makes more sense. So I need space for it to move straight. If correct, sends it straight. If wrong, sends it in the direction shown. So it needs to start as inactive because... Yeah, okay. Let's see if this works. This connects to this, this connects to this. Y goes here and here. And of course you have to come in at not the same time, so there must be some delay. Can I set the delay to be like this? Is this a bit too fast maybe? Does this even work? I don't know. Okay. Let's set it to... If wrong, then it goes down instead into the trash. Tests. If same... Oh, that's way too much sum. There's way too much summation going on. Okay, we do not want this to be here. We want this to be like at the end where it's about to... Yeah, we want this to be at the end. Okay, like this. And then these guys can be in front a little bit. So it tests one value first. If correct, throws away. Oh. Okay, well. I suppose we can change it so this happens instead. This is so much effort though. This is like the biggest thing. Oh, what? Where's my wires? There it is. Okay. If that throws away, sends out the next input. If correct. What? Wait, what? Oh, this shouldn't be triggering the holder. Anything should be triggering the holder once done. Because this only triggers the holder if it's 0, which I don't want. I want to trigger the holder when done. So I need an additional B thing. And of course these shouldn't be triggering that. This should be going out to here and here. And then this B, I guess I can use the blue wire now, triggers the obstructors instead. So transmits. If red sends it to a correct... Oh, okay. Yeah, and then finally Send it to the destroyer. Sends it to the conveyor, which will work. Oh, wait, what? Oh, right, this is not a one-turn thing. Wait, what? Oh, yeah, wait, can I? Wait. So it starts as a negative, transfers to a B state. And then it doesn't have this active state anymore, so it just keeps going. Because it's inactive now. So we need something that sets it back onto being active. Or, another thing it could do is it could just stop the object for a certain number of cycles. Because the number of cycles taken to test its value is always going to be roughly the same, right? We don't need another sensor to sense its completion. We can manually check if the completion is done. It's not going to be, you know, foolproof, because perhaps there'll be some times where... No, I think it still takes exactly the same amount of time. Like, we can count 1, 2, 3, 4, 5... Sorry. This occurs at the same time as this. So we want to hold it for 1, 2, 3, 4, 5, 6. We want to hold it for 6 turns exactly. Oh, what? Can I not set its value to... Right, I need to delete. Of course. There you go. So holds on to 6 turns. Oh, actually it doesn't have to hold it for that long. Alright. I think 5 might be enough. Let's try 4 because I'm greedy. Do you think 4 works? Okay. 4. It works! Hey! Alright, and this is in the wrong order, so obviously just push up here. Oh, I can actually push it here. I think that... no, that wouldn't make a difference. This is better. Yeah. So here... Alright. This is a horrendously large machine, but it does what I wanted it to do. Basically, it checks for value. If either of them are greater than 99, it will send one of them down here. And that will send it to the adder. If both of them are less than 99, it sends it to a value of 0, and then back to the adder. So if the sum includes one that is more than 99, the sum will no longer be 0. Therefore, going through here, it won't trigger the ending. It won't trigger the conveyor belt. So the thing will pass through freely, allowing it to be captured by S5. If they do sum to 0, that means if they're both numbers, like in this case, the 0 value will be captured. It will activate the conveyors, which will push it out into the recycling chamber. So yeah, that's pretty cool. And this works over and over. Yeah. And you go faster and faster, you'll see that it hopefully just works all the time. Yes? Possibly. Yeah, I don't think there's anything mistakes we could have made in this case. No real edge cases that we could have missed out either. Yep. Alright, speed up. Speed up. Ta-da! Oh wow, 448 cycles. This is... Okay. 12 segments. The machine is evolving. Why is your face corrupted like that? What happened to you? The data streams are flowing more freely now. I can see the patterns, connections that were once obscured. Your efforts are not just building a computer, they are building something greater. Data breach detected. Please leave the device immediately and cut the administrative assistance by invalid user. Oh, okay. Alright, you can tell I'm really low on percentile for icons used because I don't think I did this very efficiently. Yeah, all my values are really low here. Oops. You have done this in way better than I have done it. Alright, that's probably a much better way to do this. That's fine. I'm happy enough with this solution. It's convoluted, but I don't really care. Okay, that should mark the end of this episode. We finished 3 more levels here. These were some pretty challenging levels, Para being definitely the one that was most challenging. Yeah, next episode we'll continue with the next few ones and we'll see how it goes then. Until then though, hope you enjoyed the video. I'll see you guys next time. Bye bye.